Okay. Hi all. Good morning. Thanks for joining. So I'm going to talk about the shift that we're seeing, not just in the UK actually. There seems to be a sort of global move towards modern methods of construction or industrialised construction or design for manufacturing assembly. It gets called various things. But so for those who don't know, I work for a company called Bryden Wood. We've spent 27 years now developing various forms of DFMA, industrialised construction. And we've been trying to crystallise that into a sort of very repeatable approach and then use UK government backing to make that more widely available. So the idea is that if we can develop these systems, make them very, very widely adopted, you start to shift the needle on the thing that people have been talking about for decades is why is construction not more like manufacturing? How do they continue to get the benefits of productivity and safety and quality year on year? And I'm sure you've all seen the graphs where construction productivity has been like flatline for decades. So how do we start to shift that needle? One of the things that we're quite interested in is, I think people have an expectation that construction at some point will become like manufacturing. There's some really interesting things. We think there's some key reasons why we'll never quite look like manufacturing, and there's some key steps that we need to get our heads around first before we can ever step into that space. So the first one is lack of repeatability. So I think everyone knows this. The way we currently do things, every project is a prototype, every team is formed anew, and then even if that team's learned anything useful over the life cycle of the project, the team gets disbanded and reformed. And because we don't often build the same building again and again, we never sort of get into that cycle of continual improvement. So people often sort of look at automotive and go, these guys are good at it, how can we be like automotive? One of the first things, or the first thing that automotive actually did to become automotive as we know it, was just standardise and repeat. So actually there was a sort of 30-year gap between the invention of the motor car, and the first motor cars were handmade, luxury items, very labour intensive, light construction. Literally the first thing Ford did was go, just make them all the same. And that was the start of mass production. That was the big shift. So we won't ever make the kind of gains that manufacturing's done until we get our heads around repeatability, standardization, optimization. The other thing, or one of the other things, is scale. So again, people sort of have a mental picture of robots doing stuff in manufacturing, and yes, there's a place for this, but it won't, again, ever quite look like this. So in manufacturing, typically the process is bigger than the product. So if you're making a phone or a car, you have a robot that's much bigger than the thing you're making. We're not going to have 200-story robots roaming around building stuff. So we're never going to get into this level of automation. We might do it at component level, but not at building level. The kind of exception that proves the rule, people go, yeah, but what about a Boeing 777? That's about the size of a building, and that gets made by robots. But it's about $200 million. So the other big hurdle we have is cost density. So buildings are mostly air, and they're mostly commodity materials that cost pounds or pence. So an iPhone, if you had a cubic metre of iPhones, it would be about $14 million. If you've got a cubic metre of concrete, it's about $150. There's about 100,000 times more cost density in manufacturing. So again, we'll never be able to justify the level of automation and a lot of things manufacturing's done. So until we kind of get our heads around that, we'll never quite form the vision for manufacturing. So that's what we've been looking at over decades now. So where that's led us is starting again. So the solution is something around small, repeatable, cost-dense components. That's where we're going to start that's where we should start, and that's where we'll start to get the benefit. So what we started noticing in our projects was that whilst we were working in lots of different sectors, so education, health, data centres, pharma, aviation, we were starting to see lots of commonality in the solutions that we developed. So the other thing manufacturing's got is it does things at massive scale in large numbers. So we're never going to make the shift at a project level. We're probably not even going to make it at a program level. What we need to start doing is looking for commonality at a much bigger scale and starting to get into the sorts of numbers that manufacturing likes. So the term they use is platforms. So in automotive, most of the big manufacturers have a single chassis, and the stuff they bolt on makes it into the different forms of car, but they start with a kind of basic set of components they configure. So they're making those components at massive scale. That's how they start to do some of these things. So we started appropriating this term and saying, what does a platform approach to construction look like, and how would you start to develop it? So to explain platform, the best example I think everyone knows really well is IKEA. So IKEA's taken all furniture and it's boiled it down to actually a tiny number of components. So you know this whether you're making a bed or a wardrobe or a chest of drawers or a kitchen cabinet. So whichever room, whichever bit of furniture, the knockdown fittings are always the same. The screws are always the same. You only ever need an Allen key, maybe a hammer and a screwdriver. The book is always the same. So they've taken all furniture and they've turned it into a very small number of repeatable components, repeatable processes, repeatable sort of assembly steps. And what it's done is changed furniture making from, again, like construction, used to be very labour intensive, very expensive, very bespoke. Suddenly everyone can make furniture. So the labour pool of people that can make furniture is like everyone in this room and beyond. But you also know when you go to IKEA, you don't buy a wardrobe and stick it on the roof of your car and hope it doesn't fall to bits on the motorway. You buy it as a little kit of parts. And when you get it home, you don't build it in the drive, you build it in the bedroom. So you intuitively know that kit of parts, logistically compact, put together at the point of assembly, that's where we need to be heading. So in the UK, definitely there's a move towards off-site, and people are trying to replicate building things in a shed, and you go, well, now I've got the cost of the shed and the transportation, and I'm now going to lift a big heavy thing. So we think that's probably not the way to go. Getting more like IKEA is probably where we're going to start to see some gains. So we did a thought experiment with a load of the key departments and said, if you plotted everything that government buys, it lives on that graph somewhere. So there's a thing in construction where people focus on the differences between sectors. So healthcare specialists are like, oh, stay out of healthcare, so complicated, and resi people are like, oh, you can't understand the pain of resi. So people tend to accentuate why their sector's different, and therefore that sort of starts some of this thinking. If you looked for commonality, you'd find absolutely tons. So for instance, floor-to-floor heights are person height plus a bit, and at that sort of height you can get natural light about 8 metres into a building. So that's why schools and apartments and healthcare wards have the same spans. It's nothing to do with sector, it's because they're all based around the same unit of size, which is a person. So if you started looking for those sorts of commonalities, you'd find loads of them, and that would start to reveal the IKEA kit of parts. So we did this experiment and said, look, if you plotted everything that government buys, you could imagine a kind of small cellular kit of parts that would do things like prisons, so Five Wells was one of ours, student accommodation, single living accommodation for the army, for instance. Probably got a big empty sheds kit of parts that would do kind of gymnasia and sports halls and things. Almost everything else sits in the middle. So there's tons and tons of building types which have that kind of mid-span because of the reasons I've just talked about. So if you had a kit of parts that did mid-spans really well, you could buy billions of pounds worth of this stuff. That gets you into the scale of manufacturing that everyone likes, and suddenly that's how you start to shift the needle. So this is now, the government picked this language up, and this is their definition. They say, we identify features of assets that could be shared, harmonise those features, use that to get the kit of parts, and use that across sector to get into the scale of numbers, the repeatability that manufacturing likes. So this idea has become very sticky, certainly in the UK government, but we're starting to see more and more interest from big serial clients in the US, in Asia. This idea is starting to get traction everywhere. So why would you do that? Well, if you had fewer components to handle, firstly you'd optimize those components, use less material, then you'd get into economies of scale, then you'd get into the manufacturing mindset of continual improvement, and you'd also do the IKEA thing of de-skilling construction. So one of the big challenges everyone's got is skills gap, aging demographic, lack of people. We've used this to build, say, pharmaceutical facilities with ex-British Army people. We've built bits of the prison estate using prisoners. So in the way that IKEA's boiled furniture making down to a series of simple steps, you could do exactly the same in construction, and suddenly your labour pool becomes ex-services, serving prisoners, ex-prisoners. You massively diversify the number of people and solve the skills gap, which is another sort of key reason why government's dead interested in this. So we've been on this journey as Bryden Wood for 25 years, 27 years now. The last 5 years particularly, we've started to get more and more traction. So we published a book. You can download it from our website. It's brilliant. I would say that, I'm biased, but we kind of set out this vision back in 2017 and said only government can do this. So no individual client has got a big enough pipeline. Even the likes of Heathrow and some of these mega projects aren't big enough to shift the needle. The only people that can do this is government, because you've got the biggest pipeline, the longest pipeline, the most persistent interest in the assets. So we set out a vision of why government could do it, how government could do it, and that wasn't just us, but that kind of started this thinking that's become more and more persistent. So over a number of years now, you can see a number of key documents that have been published that have firstly articulated that vision in more and more detail, and it's gradually become sort of part of central policy. So in the last couple of years, things like the construction playbook was published in the UK. That's the 14 key policies that all public procurement now has to follow. And one of the things it talks about is we're going to buy things using platforms. So it's now become a sort of central tenet of the way we deliver social infrastructure. So one of the things we had in that book, on the right-hand side, we said rather than go through all these sort of like endless tiers of tier 1 employs, a tier 2 employs, a tier 3 employs, an assembly crew employs, people right down at the weeds. If you had this sort of library of digital components right at the front of a project, you wouldn't design things from scratch in the same way. You wouldn't have the kind of normal sequential linear process. You would be configuring things. So you could have a digital library of components, really well defined, rule sets really well defined. Design teams then configure them in the way that you configure your Billy bookcase or your IKEA shelving unit. And that's how you'd start to get allow site-specific designs, but using standard components. So one thing automotive is very good at is giving you lots of choice. So when you buy a car now, you get endless choices. You can make a thing that's quite bespoke to your needs, but it uses completely standard components. So we're trying to do that for construction. On the left-hand side, you then get physical components that you can get almost anyone to make, put them together using almost anyone, and that's how you start to solve this tension. So I'll skip over a few of these documents. This got published. Infrastructure Projects Authority, who sits between our Cabinet Office and Treasury, picked this up sort of end of 2017. They set up a thing called the Construction Innovation Hub to help sort of scale this idea. And then one of the first outputs from that was a thing we called Defining the Need, which was saying, right, take that thought experiment and do it for real, and what does it look like? So we got £50 billion worth of forward pipeline for these big departments. So it wasn't all of their pipeline. So we didn't have all of defence, for instance. But we firstly took their forward look. We put it all into Uniclass, which was an absolute nightmare trying to get stuff into a common language. So for classification fans, I love a bit of Uniclass, but it's a way of categorising individual spaces using the same language regardless of department. So one of the things that was getting in the way was that every department has its own naming convention. So once you put stuff into Uniclass, you could then cross-compare much more formally things like the spans and the heights and look for this commonality. And we found some really interesting things which didn't surprise us necessarily, but it did prove a point. So top left, when I talked about that mid-span platform, we found that 70% of the buildings we looked at